me a second here.
There we go.
There we go. Hey, hey, Hosta Nebula, everybody, especially our outreach guy that uses that. Stargazers everywhere, especially in Southern California or Central California. Welcome aboard our SBAU Astro Hour, episode number 68. I'm hearing myself repeated.
Nebula, everybody, especially our outreach guy that uses that. Stargazers everywhere.
It's the old radio voice. Anyway, number 68. Thank you for turning that down. June 13th, Monday through the 19th, here in Santa Barbara, California. I'm Ron Heron, proud to be vice president of the club, and we'll meet some of the other board members here in a minute. Santa Barbara Astronomical Unit, South Coast Longtime Telescope and Astronomy Club, convenes every Monday morning from our men's caves and dens of computers. We're on Zoom, but you can watch online Astro Hour on YouTube. And there's a lot going on in space, and let's meet the SBAU Brain Trust. But first, what are we going to talk about? Planets are in line out there in the night sky. A micrometeorite impacted the Webb. Oh no, got a super moon, strawberry moon, your choice, honeymoon. It's about to fill up. Check out Corona Borealis this week and double star up in Cassiopeia's Big W. And we may get to talk about sunspot cycles and learn something I didn't know about with the president, Mr. President, now serving as temporary webmaster, Jerry Wilson, whose wife just mic'd him from the left, Pat Forgy. 3 or 4 years. How many years now? We've been.
I don't know.
Well, it's all right. It's been 2 years of sitting in our. Yeah. Chuck McPartland is our outreach guy, and he's darn good. His wife is Pat, and she's the merchandise manager. Also on screen, joining us early was Bruce Murdoch, who's married to Bonnie.
Hello.
And Bruce is on the mend and got his ribs back. It's those damn loners they give you when they take them into the stoplight. Just hate
I
them.
can laugh now too. It doesn't hurt.
And
Well,
Tom Whittemore is Captain
Morning.
Sourdough, former Westmont College science instructor, editor of the newsletter, SBAU newsletter, which we got a little late this year because it's delivered by our illustrious wide brim hat treasurer man, Mr. Colin Taylor. Tim Crawford may be listening. I want to say hi to an old buddy up in Southwest Oregon in the little town of Coquille that's probably watching us. And he came to a couple meetings with me once. That would be Ian Trenwith of the Trenwith brothers that used to own and run one of our great catering companies called Jolly Brothers. Okay, I gave you the headlines. We got silly stuff to talk about. Where do you want to go first? Your forwarded science cartoons, Jer? Because you got a bunch here. There's a backlog here.
Yeah, we can.
We like to start with a little lightness, a little levity, if you will. And some of these are great. One is also a repeat. Oh, that's the repeat. Yeah, that would be.
Oh, is that a repeat?
Yep.
Yeah.
Okay.
Well, that's okay.
Sure. I lose track.
People watching are gonna want to know. I missed it before. See what he calls up here, and if I can match. There's quantum physics, there's student loan debt, there's solar system. There it is. It's the solar system new schematic, a new view going outward from the sun. The planets are now Yuma, Phoenix, Tucson. Then you got Earth, Mars, Jupiter. Yeah, those are the hot planets. Actually, they put an extra one in, I think, between us and the sun, didn't they? All right, how many more you want to go to? You're getting good at this, Chair.
Yeah.
We may not need Tom Totten anymore.
No, we need
Oh, I
them.
like this one.
I knew it. That's how you headline this one. Strange alien and its spacecraft land in a field on their side, tells the man on the edge that discovers them in reverse text. Your planet is sideways and your language is backwards. Yip, whoop, yip, whoop. Hold that one up to a mirror. Okay. Got any more? Or you want to go right into the subject matter? We got a lot to talk about. I have a feeling one's coming up here, guys. There it is. Oh, this one I didn't see. Oh, wait a minute.
It's this morning.
Oh,
I didn't get this one.
But you see, those are all the lost socks.
Oh,
come out of the-
okay.
And
Oh,
the other end of the
that is-
wormhole is the dryer.
Okay, I didn't get them as socks. I
I
thought
didn't
they're just
either.
piles of garbage.
Same deal.
Yeah.
Okay, we'll move on to the science now.
All right. Well, let's talk about the breaking news there's not much to say. We pretty much know, and it's even made regular national headlines and news about the James Webb Telescope, which is in position and ready to start shooting, I think, regular pictures and doing its job. But what happened, Mr. President?
Oh, it got hit by a very, very small, Bruce claims a 1/10 of a millimeter or 100th of a millimeter diameter meteoroid. Knocked one of the mirrors off kilter, but they're still going to go ahead with their release of the first official science images on July 12th.
How do they know it? Does it have a hole in it, that piece of the mirror?
That depends entirely on how thick it was. I didn't read any damage report.
Okay.
It's probably just a small crater in the beryllium and the gold coating. But you know, Chrissy at the museum, they are connected with the James Webb in that when there are releases from the James Webb, they get sent to the museum, and the museum was going to have public events to reveal the images as they came down. And she was bummed that the first event was going to be on July 12th because that's a day that the museum's closed. and so she was hoping that this impact would delay them by a day, but it doesn't look like it will.
No, I don't think so.
Is this going to be a regular problem, you think, with the James Webb Telescope?
Hope not.
I don't know. We were speculating in email that, at least I was speculating that the L2 Lagrange point might collect orbital debris like ocean gyre does.
Of course.
And Bruce had some comments on that too.
Yeah, I sent you a link to I forgot where it was that shows that radially it's a repeller, but angularly it is an attractor. So that's really not a really good place to have your thing if it's going to be attracting junk.
Yeah. So time will tell.
Tom Whittemore, did I introduce you?
Yes.
I
think
with baking bread.
I think
Mr. Sourdough.
All right, that's your new name. I'm going to place my order soon. Just a couple of quick notes in case, so we're up to date on things. Perseverance, which is the last NASA rover we sent to Mars last year, picked up a rock on one of its wheels. What are they calling it, Chuck?
Pet rock.
Pet rock.
And NASA
keeps the rim clean.
Yeah. Somehow they got a picture of it. Is the camera, they can make that camera go anywhere they
That's
want.
on a boom.
Oh, okay. They didn't come in with, the helicopter didn't, or whatever that thing is called.
No.
Ingenuity. And then NASA's joining the hunt for UAPs. Does the U in that new term stand for unidentified or unauthorized?
I think it's like unexplained.
Is it unexplained? I don't think, okay.
Just
Yeah.
Just all right. Aerial phenomenon. Okay, gentlemen, always want to start close to our neighbor out in space, which is getting a little close to us because we got not one, not two, but three names for the moon, which is about to fill up this week. As a matter of fact, it could be the strawberry moon. I'm not sure why that's called that, but I think Chuck will tell us. It'll be a super moon as well as a honeymoon. That's from an astronomy magazine columnist. And it's going to be at perigee. There it is. Can't be how it looks. Maybe now.
Yeah, this is not the strawberry moon, and this is not even a full moon, but it's very close. This is a moon that illustrates the coloration of this month's moon, because the moon this month, why it's called a strawberry moon, is because it's so low in the south and it has to travel through a lot of air, which preferentially scatters the blue out of the beam.
It's in Scorpius, Ron. It's real low.
Yeah.
Well, Jerry's talking point says it's not as pinkish, but more yellow. And why honeymoon? I don't know that. I guess strawberry moon.
That's because of the yellowish.
Oh, is that what it is?
Kind of an amber tone.
My guess is that it's a honeymoon because it's in June, and June is the traditional wedding month.
That's it, exactly. Right, got it. Golden hue. So can we throw away the strawberry part? That refers to color, right?
Well, that was probably also referring to when strawberries, start forming. It's sort of a late spring, early summer thing.
Yeah, okay. We're going to have a couple hours without it in the sky after, what is it, tomorrow night?
Yes.
And the sun will set, and then there'll be no moon for a couple hours. And so does it really make that much difference? Does that little speck of half a degree flood out the rest of the sky that much?
Yeah, yeah. When it's near full, if you graph the brightness of the moon relative to how much is illuminated, when it gets near full, it suddenly jumps by like an extra 10% because the mineral crystals on the whiter looking areas of the moon you see are anorthosite, and they have tetrahedral crystals that are like those little things you see on the sailboats that are up on the mast that amplify the radar returns. They're very good at reflecting radiation right back from the direction it came.
There are some of those sitting on the moon near the Apollo landers too.
Yeah.
So they can measure the distance to the moon very accurately.
Well, those are mirrors that they use there, but they're in a tetrahedral form. Yeah.
Yeah, cube mirrors. It's the corner of a cube.
They're corner cubes.
Would it be a fair statement to say that a full moon isn't really as preferable to you guys as a crescent or a half, where you get some shadows?
It looks much flatter when it's full, so you don't get the dramatic shadows and things. But it is good for showing the splash marks where you have the debris knocked out of the big younger craters.
You know, I was also going to comment on our second Saturday star party. First of all, how was it on Saturday night? You have a lot of visitors?
We had 257 visitors. We did get clouded out by about 9:30. And we were sort of playing with the marine layer for quite a while. But the moon powers through it a little.
Uh-huh.
Well, my memory serves me correct in that little driveway that goes up to the museum's observatory. There's the most part of the museum is on your left. There's some trees around you. There's a big hill with the mission beyond it to the south of us. We don't have much of the sky to look at when we're doing those things. It's straight up pretty much.
It's not horrible. From down in the pit, you can look up over the buildings and see a fair amount of stuff.
Okay.
Look at it this way: we are limited to the best part of the sky.
Yeah.
Okay. And so you look out if you get one of the big planets, or could you see all of them lined up? Because they're still in a line, I think.
Well, Ron, that's only pre-dawn.
Yeah.
Oh, that's really? Okay.
Yeah, the museum does not have a good eastern horizon.
Nor western horizon.
Well, you did have 250 people. I can't imagine how many people set up scopes besides
We had 9 telescopes set up.
Bruce, you're not coming back yet.
I'm sorry. Pat's saying it was 6. It was 6 telescopes, nine people running them.
Okay.
One of them was the observatory scope.
Okay.
Did you say Tessa Flanagan?
No, she wasn't feeling good, so she didn't come.
All right.
And there's a new guy at the museum named Sean, also like Sean Kelly. I guess we can call him Sean Jr.
Right.
Sean Fox, who is going to be Chrissy's new sort of assistant, and he was running the big scope.
And can we tell anybody? I know it's early, but it's a month and a half away. We're going to try to open in August, aren't we, Mr. President?
Yes, we're going to have try for our first in-auditorium, in-person meeting on the first Friday night in August.
That's the 5th.
August 5th. Okay, at 7:30. It will also be Zoomed at 7:30 in a format that a large number of people can view. I forget the word for that.
Webinar.
Webinar, yeah.
Thank you.
You know, COVID has not gone away, and only 66.6% of the people in Santa Barbara County are vaccinated. And I've got people that troll the internet for all kinds of reasons why they shouldn't be vaccinated. And if you take a look at the charts, they have weekly, the infection rate by week plotted, and it's all of a sudden has a big uptick.
Yeah, we're watching that. Plans may change.
I wouldn't go with that kind of, hospitals are where you get sick. And when I went to the hospital, immediately after the injury, they put me on oxycodone and sent me home, I guess, 2 days later? And then I was hacking my guts out, and I went back, and I didn't have a fever or anything, but they found out through the throat swab that I had parainfluenza 3. I had a viral pneumonia. And there's nothing they do for that. There's no medicine they give you. It's just palliative. And it's taken me a good month to get over that. To get my lungs
I know
clear
2
out.
people that have parainfluenza right now, and I know 6 people that have COVID. But I will be in Ferrand Hall with a mask on. The doors will be open, and I expect the turnout to be very light. But plans may change. But thank you for that, Bruce.
Yeah, I don't want to be in places. I'll probably go this Friday to Refugio, but because you're outdoors, you can be distant from people. But I don't want to go to Ferrand Hall.
Well, Bruce, Refugio isn't on Friday. Refugio was last Friday.
Oh dear.
Refugio is going to be on Wednesday night.
Oh, because Chuck Schuler called me and asked me if I was going.
Yeah. And Friday night's Westmont.
Oh, maybe. Okay, Westmont. That's what. All right, fine. I can go to Westmont.
But you'll wear a mask.
Oh, definitely.
Well,
Yeah.
And if somebody approaches my scope without a mask, I'll ask him to stand back. You may look at my scope as long as you stand 6 feet away.
I got to tell you, I use the downtown supermarket. Ralph's is my judge and standard. They're not wearing masks, but I do when I'm in there and on the street.
Well, let's get back to the
Dark
astronomy.
Okay.
how about the sun? That will take some
You
time.
want to go? You want to go to the sun? All right, that was.
I know Tim was wanting something on the solar cycle.
400
And he was texting me about the Maunder minimum.
the what?
The Maunder minimum. It's in the talk.
Okay.
Yeah, it's from up till about 1750 or 1725.
Mondorminium. How about a sunspot region called AR 3030?
We'll get to that.
Okay,
Here-
400
Can you
years.
see this okay?
Yep.
Okay, this is, Bruce, you're upside down.
What do you mean?
Okay, Maunder minimum back here between 1650 and 1700.
Well, I
Obviously
said
not.
1730. It ended up. It stopped.
Okay, I was just guessing from this chart. So about
Well,
there,
so am
about
I.
1700. Okay. And here's actual counts starting back in the 1750s. I guess up in here is when Galileo first started looking at things.
And those are
the sun.
estimates.
Yeah, these are all estimates. You can tell they're in red. And the rest of the chart, based on measurements, is in blue. And we have a sunspot cycle that switches, every 11 years with a real cycle of 22 years. So these peaks are set apart by 11 years. Is that right?
Yeah, the sun's magnetic polarity reverses every 11 years.
Yeah,
It takes 22 years to get back to where you were.
exactly. And the whole thing about sunspot minimum and maximum is all due to the magnetic field of the sun and how it couples to the plasma that is the sun. And so let's see if
On that graph, Jerry, back in the late 1700s, they were measuring the number of spots on the sun.
Yes.
How would they do that?
now,
They look at the sun and they count them.
I ain't gonna look at the sun. I don't know about you.
Well, you smoked glass, amongst other things.
Is that how- is that
Or
how you-
projection onto a piece of white paper. That's
Yeah.
what Galileo did.
Oh, pinhole camera, huh?
Okay, now are they coming around the sun in different areas? Or are they only on the
as
equator?
the sun rotates, we'll get to that. First, I
Okay.
want to give you a short 3-chart briefing on magnetic fields because that's key to this.
Versus electric field. I didn't know there were two fields.
There's an electric field, which is this is the electrostatic field between two fixed charges, one positive, one negative. And these are monopoles, for example, a proton and an electron. And the field lines start on the proton, for example, and they end on the electron. Magnetic fields are not like that. Even though this suggests that's the case, it's not. Magnetic fields do not start on a particle and they do not end on a particle. If you can see inside the magnet, these particles, this electric field or magnetic field goes around here, then it goes back, and it's the same electric field in a loop. And and I'll show you that.
There are no monopole magnetic fields. They're all dipoles.
Right. Let's see.
Yeah, what would be neat would be an animation showing a single electron or proton and a field around it, and then bring the other one in, you know, so you see how the field changes, so you can see that it can just emanate from a single particle.
Right. So we're basically going to do that, but not in a nice graphic like you just described. More klutzy. This is a wire, and there's an electric current going through the wire like this, which is, and brace yourself, the flow of positive charge. Actually, electrons move this way. They set down on a definition before they knew what they were doing.
Benjamin Franklin didn't know which way it went, so he just made a choice.
Right,
He was
and
wrong.
that was it. So, but that sticks with us today. So that produces a magnetic field around this wire that is represented here by these circulating loops. And this shows the magnetic field due to a moving electric charge. And the charge is moving to the right. And if you put your thumb in a, called the right hand rule, if you put your thumb, now this may be reversed. This is my right hand. So that you stick your thumb out, so that points in the direction of the current. Then your fingers curl in the direction of the magnetic field. So that's a way you can remember how the magnetic field goes around a single, around the, right. So,
But AC versus DC.
Well, it reverses 60 times a second.
Yeah.
60 times that field reverses?
Yeah.
Every 120th of a second, it changes state, changes the sign.
No, I didn't get this right here. Anyway, forget the word type equation here. I captured it too soon. It shows two electrons. E minus is the symbol for an electron in physics. And B is the magnetic field, and V is the velocity. Here you have an electron moving at a velocity V greater than 0 in this direction. So the current is this direction. And this is the right-hand rule B field, which is a circle around the electron. And then here we are sitting on this electron at rest, and there's no magnetic field around it. Now picture a stick figure standing on this electron that's moving. Well, he would feel no magnetic field, and he would look back at us, and we're sitting on this one. Our electron would appear to be moving this way, and so we would have a magnetic field around us from this guy, according to this guy and his instruments. So it's relative to the motion of the electron. Now, if I haven't confused you yet, let's see. Around the wire.
Well, we make electricity using magnetic fields, don't we? Whether it's dynamo.
Exactly the same principle.
Yeah.
You have a wire in that's being rotated through a magnetic field, and it creates a voltage across the wire.
But then what is
a current? Actually, a current in the wire.
But that's a magnetic field around the wire, not an electrical field.
Right.
They're coupled. They're all part of the same Maxwell's equations.
Magnetic fields and electric fields cannot really be separated from each other. A magnetic field is the result of motion in an electric field.
Okay.
So this shows a picture of the sun, and the sun is a ball of plasma, positive charges and negative charges, and it has an angular momentum to the sun, but because it's a fluid, it rotates at a different rates at the equator. You see, it has a bigger velocity than it does as it goes toward the pole. So it rotates around here faster. So the
You'd think it would be just the opposite. They'd rotate faster at the poles, at the closer you get to the poles, because there's not as far to go.
Well, think of yourself standing on the equator, Ron. You're going 1,000 miles an hour. At our latitude, you're going 700. At the pole, you're going 0.
Well, that's a solid object. You're on a solid thing that turns as one ball.
Yeah,
The sun
but
isn't.
it isn't.
And if you're at the pole,
it's very
if you're
similar.
at the North Pole, the only direction you can go is south.
That's true, but the ball is not, it's not a gas cloud. The difference, I should have emphasized this point, the difference between the sun is it's a plasma, and you can't move charge without creating an electric field or a magnetic field, and the magnetic field locks to the charges that created it. So they're not free to just flow like the jet stream is on the Earth. Jet stream does not have any magnetic field associated with it. The sun, it all does, so it's locked together. It's more like a rigid rotator, but to an extent. The field is called magnetohydrodynamics, and the math scares me off, but it's pretty straightforward physics.
So you get like drag in effect. So the individual sort of bunches or particles in there, you can think of them as sort of coupled a little bit by this drag force.
Right. So now with current, for example, with the sun's rotation due to current, there's several currents, but current would go from this edge all up toward the back of the picture this way, and it would create a magnetic field line. This would be largely inside the sun. These are convection cells where hot plasma rises, cools off, gives up some of its heat, and goes back down. This also creates magnetic field lines that go around this way in a loop inside the sun. But as the sun rotates differentially, it starts twisting the magnetic field up. And pretty soon the magnetic field can actually break through the surface of the sun. And where it comes out, if you look at the polarity of the field lines when they come through the sun, sunspots occur in pairs, and one is always North Pole and the other is always South Pole, although they might be mixed up with other things. But the basic idea is there.
Yeah, the graphic is wrong. You notice the circulation on the cells is the same direction on both entrance and exit.
I don't see any arrows indicating circulation.
Well, you have the convection cells, and they're showing the direction.
Oh yeah, these are two mechanisms here. These are the convection cells, which are not producing this. And then flow due to rotation is going through the surface like this, and that is producing this line. But you have several of these things going on. You have more than one simple source.
And is there an average of these black sunspots? You say they're always in pairs, so that means we always get an even number reported?
Yeah, but they can be distributed. Yeah, you tend to do that, but you can always, you can usually find some other polarity one, but some of them it's spread out. So let me see, EMB field, eta, differential rotation of the sun. Let's see.
Plus, if something brings them in a close proximity, they can in effect merge and reconnect, and that's when you get a flare.
Or a CME.
Yeah, here it shows the rotation. This is due to plasma rotating with the sun and the sun's surface. And here you start out with a nice orderly, if the sun rotated, at a uniform rate, you'd get this nice magnetic field like we do at the Earth and at Jupiter, although there are variations in that too. But it starts looking like this as the sun does its differential rotation. And it starts twisting these lines up. And then it keeps going until you get very twisted up. And it gets so twisted up, these things, it takes a lot of energy to break a magnetic field line and reconnect it. And after it gets twisted up, in 11 years, they start coming through the surface of the sun and forming these sunspots. Now, coronal mass ejection is where the sunspot, the magnetic fields that produce the sunspot, stick out so far from the sun and contain so much energy, and they've locked in so much plasma outside the sun that then the magnetic field breaks and reconnects. So now you have a free floating piece of plasma with its own magnetic field that has been shot off the sun and headed for the Earth. But this is just how the sunspots go with the cycle.
And the magnetic field on Jupiter, Jerry, the magnetic field is really weird because there's multiple poles.
Right. Yeah, I'm doing just this. Look on truth as a power series, and I'm giving everybody 0th order term. Yes, there's complications on all of this. And one guy's actually running an experiment with a sphere that he's made out of tubes, and he's filled with molten sodium. And he's trying to understand the differential rotation and the complexity of patterns that are created. So I don't want to be in that room if the tubes break.
But if that stuff's thrown out to the earth, does it ever hit us?
Yes. Oh, yeah. If it's aimed wrong, we get it.
That was the Carrington event in the late 1800s.
Yeah.
1849.
Okay.
They didn't have too many satellites up back then, did they?
No, they had telegraph wires.
Oh, that's right.
And they had arcing at the poles. They were able to send the telegraph signals without the need of batteries.
Wow.
And they
if that happens today, with our wired infrastructure, standby to standby, I mean, it's going to be something.
I heard.
And it's a big problem because there are something like 7 big transformers that are used in the grid across the nation. And they're very expensive, so nobody made any spares. And if those get fried, it may take years to recreate the grid.
Yes, that's the glory of American business is short term, only what happens in the next quarter.
Same thing about politicians.
I think most of our bad feelings about politicians is really due to corporations. But anyway, enough politics. This is our current sun over the last few weeks. This is a magnetogram. The contrasting colors show magnetic fields coming through the sun's surface and going back into the sun's surface. So there's roughly the same number of gazautas as there are gazentas because they're opposite polarity, even though they may not latch up one-to-one nicely. This is a current sunspot system that's very active called AR3030, and it's coming around the sun, probably about here today. And this is a map of the magnetosphere of the sun. So it shows what's happening, what's breaking through the surface due to the convections, the sum of the vector sum of the convection cells and the differential rotations. So
NASA came up with that AR3030 number?
I don't know how they number those.
They fired a rifle shot at it to get it.
We have a probe out there, don't we? The Taylor and what's
Parker.
The Parker probe, yeah.
When do these sunspots peak? At the beginning or the end of the 22-year cycle?
The middle of the cycle.
Middle.
Right. So in between changing polarity of the whole damn star.
Yeah, you think of it as a sine wave. You know, when you're up at the peak, that's where you get all the sunspots, and it starts to go down, and then it reverses.
Okay. And just for my own edification, the direction the sun turns is the same as the direction of the planets. Are we all going?
Yeah. Yes. It's the whole solar disk, all still holding hands. Now this is what's called a butterfly plot. Excuse me, you want to say something?
Except for Pluto, doesn't it go the wrong way?
No, it doesn't.
But it's out of plane.
I know that. Okay. Oh, that's right. One of the outer planets rotates the opposite way.
Right, and Venus does too.
This does too.
Okay. Oh, they think Venus might be an interloper, right?
No.
It might have been captured.
No. It just got whacked by something when it was forming.
Oh, okay.
Capture into a nice circular orbit is hard.
But it turns the other direction of all the other planets?
Yes.
Yeah.
Venus? Wow, I didn't know
Sun rises in the west and sets in the east.
Be damned.
So you might not make it between one sunrise and sunset. This is a butterfly plot of sunspots on the sun. The line through the center, right down here, EQ, that's the equator of the sun. So the North Pole is here, 90 degrees north, South Pole is here, 90 degrees south. And you see, this is time going this way. So sunspots, for example, here in 1915, they start at the nearer the poles, and as the sunspot cycle goes on, they move toward the equator, and then a next series starts, and they start near the poles, and they move toward the equator.
So it's not showing our 2022 here, but that AR3030, you notice, was kind of at a high latitude. So it's the beginning of this next cycle.
Yeah, this chart was made in 2016 in October.
Yeah.
So.
Or are we saying, are you looking at two of the mirror images of each other, one in the northern hemisphere of the sun and the other in the southern?
The spots tend to start at the higher latitudes in either hemisphere.
So at the same time, there are spots here, there are spots here.
Wow.
But but right here, there's none near the equator. So they're all in northern latitudes and southern latitudes.
Okay.
And later here, they're very close to the equator, at the equator, but there's none at the higher latitudes there and none up in here.
Would these yellow blobs be black on the sun and that's what the sunspot looks like? Or is it just another little spot inside the yellow patch we're looking at?
This is a summation of the area of all the sunspots that are on the sun. So the color tells you how much area of the sun is covered by the sunspots. So you can see the little up at the very top right of that graph is the percentage of the surface of the sun that's covered. So that's all the color's talking about. It's kind of like how many spots there are.
Yellow means a lot. Black means almost none. Red means, in the middle.
Or small, very small ones,
Yeah.
I missed the black part. What does black mean, Jerry?
Black means almost none. See, less than zero.
It's not a
Or
whole.
it's greater than zero, but less than 1/10 of 1%.
Okay, there's plasma there where that black is. That doesn't mean it's
no, Ron. This is just a graph of the count of and the amount of area of the sun.
Right.
It has nothing to do with whether there's plasma there or not, or temperature or anything like that.
And you
They
can see
could have made these colors orange and purple and yellow, but they chose these colors.
Yeah. Those are false colors. They do not represent anything real on the sun except the number of spots.
Yeah, so Ron, you can see in the late 50s that the sun was coated with a lot of acne.
Had a pimple problem. Okay. Always wondered about those. Are they deteriorating, getting lower in number, or firing up and more?
Here's the total number displayed sideways without latitude, just on the total sun. And you can see they've been generally increasing to 1960, took a big dip then, and then they've been coming down. We had a real quiet year in 2020, actually, and now we're getting a more active year this year.
Wow.
So it's multiple cycles that are overlaid here.
Yeah.
There's the main 22-year cycle, but there seems to be another cycle in when it's a really active cycle or a quieter cycle of the 22 years.
If you do a Fourier transform on this stuff, you get all the harmonics, and there's a number of harmonics buried in there. We've only been taking them for about 150 or 200 years with any accuracy, and some of the cycles that are implied go beyond that. So that's yet. I should have hunted up excuse me. I should have yeah.
I can't help but I keep thinking that electrical flow or magnetic fields require metals, elements that are
conductors. But plasma is a conductor. They require a conductor, something to carry the electrons.
Yeah. But down here on Earth, we have non-conductors, which are silicone and
Silicon is a semiconductor.
What's a semiconductor? But we know that metal is the iron filings. The fact that wires are made of metal, and we know that the whole world of electricity and magnetism is around metals.
Well, Ron, think of an atom. It's got electrons that you can think of as moving around it. Okay.
So
there's going to be a magnetic moment to that.
But hydrogen doesn't conduct electricity unless
it sure does. If you get it at the right temperature and pressure.
Oh, very well.
You make it a liquid, you can get metallic hydrogen it conducts.
You don't even need to be able to conduct electricity with an atom. As long as an electron is going around the atom, that constitutes a current loop, and it will make a donut-shaped magnetic field in the atom. But the atom will exhibit a magnetic field that is the vector sum of all the motions of all the electrons and all the protons. And some of them have no magnetic field. Some of them have a magnetic field you can disrupt or line, like in iron. it has a magnetic field. And if you put it in a strong magnetic field, it will line up all of the atomic magnetic field lines so that when you take the magnetic field away, the iron now has its own magnetic field. And because the atoms are no longer randomly tilted, all their planes of orbit line up. And so that was a bad image, but until you heat up the iron and randomize everything, or you hit it very hard with a hammer, which re-randomizes everything, and then its magnetic field will go away until you put it back in a strong field to remagnetize it. And some magnetic
And also heat it up.
Yeah, heat it up either way, yeah. Now, some materials that are not magnetic, for example, aluminum, are diamagnetic, which means if you put it in a magnetic field, it makes a magnetic field inside itself to counter the magnetic field it's applied to. So if you take an aluminum tube and you drop it down, you drop a permanent magnet down through the inside of the aluminum tube, it will create currents in the wall of the tube, which then, because of the resistance of the aluminum, will counteract the fall of the magnet. And it will take a long time, an abnormally long time. It will not free fall through the tube. It's called magnetic braking.
But you get that same thing no matter what, as long as the tube is conductive. It can be a copper tube or.
That's right. I just picked aluminum as an example.
But so, see, that's eddy currents as opposed to diamagnetism.
You're right. I mixed to it.
And
let me put it this way. Magnetism is what?
It's a dramatic display.
Yeah.
Right.
Magnetism is a wonderful and varied field. It will need several of these hour-long talks by itself. We can put anyone to sleep with it. Okay. Well, this is magnetic fields on the sun, showing in 5-year increments here, showing the magnetic field lines on the surface that follow the population of the sunspots.
So there's a mini butterfly diagram in there.
So
right.
Can you sum up, Mr. President, in just a few words, what the heck an electric field is? How is it different from a magnetic field?
If you have an electric field and you take a charge, like an electron, I hold it in my tweezers, and I put it in an electric field and I let go of it, it will move opposite to the electric field. So, and if the electric field is created by charges, you can have a static electric field. You can't have a static magnetic field. Magnetic field is like a motion of an electric field.
Wow.
Permanent magnet has a static magnetic field.
But it's due to motion of electric fields.
Right.
So all magnetic fields are due to motions of an electric field.
Charges have to move.
Yeah.
Charges must move to get a magnetic field.
Okay, yeah, it's the magnetic moment of the iron.
Yeah. Okay.
Okay, Ron, and here's a good one for you. A photon is like a little electric field that's oscillating, but it's creating an oscillating magnetic field in an orthogonal direction to that. So one's up and down and one's left and right. And basically each one influences the other, and that's what keeps the photon going.
That's all energy.
Yeah.
And yet it can stop on a dime and stay there where it stops in an atom before it's ejected again somehow. It's just energy.
You can store energy in a magnetic field by putting a loop of wire and having a current run through that loop, and then it will create a big donut-shaped magnetic field around that loop. And as long as there's current going through that loop, it keeps that magnetic field stable and stores energy in it. If you shut off the current to that loop, and it's not a superconductor, then the magnetic field will collapse and it will keep the current going in the loop even after you shut it off until all the energy is drained out of the magnetic field. If you do make the loop out of a superconductor, it's a good way to store electricity because the current will continue to flow in that superconducting loop until you drain it out again. So as long as you don't drain the energy out, you have this tremendous magnetic field that stores all that electrical energies.
Is that how you guys as Teslas run?
Not quite.
No.
They don't have a battery yet based on what he just said, I guess.
Oh, we make them in the lab. The thing is, it takes so much cryogen to keep the superconducting. This is a current picture of the sun. I think this is from about 3 days ago. This is Sunspot group 3030 coming around the bend. The Sunspot group is probably about here now. And then this is that Sunspot group AR 3030 in hydrogen alpha coming around.
So you can see the plasma suspended by the magnetic fields.
Right.
Suspended by the hydrogen.
The plasma, the field as it breaks through the surface, it interacts with the ions that produce it. They're not separate entities. So if the magnetic field is forced out of the sun by all this twisting, it lifts up plasma with it. And as it gets out here in rarefied space, a lot of that plasma material becomes oriented and cooler and it falls back into the sun. But the magnetic field can move up, and I'm sure you've seen these in big loops like this, and can stick far enough out that then the magnetic field will break off and reconnect, releasing a lot of energy. And then that loop and plasma will fly off into space and become a coronal mass ejection. So this is a fairly active sunspot group that's coming around the sun right now. It's probably over here by now too.
It's in the equatorial area, the middle?
No,
No, it's above, definitely above.
the previous picture showed it. It's at a fairly high latitude.
Oh,
But it moves toward the equator as it ages, right?
Not as it ages, but new ones are produced closer to the center.
Yeah.
It doesn't actually, there's the sunspot group right there. It's about, what is it, about 30 degrees up?
Yeah. 20,
So,
25, something like that.
yeah.
Yeah.
Later, the newer sunspot groups will be produced closer to the equator. And then they'll have different polarity, but they'll start up here again. Then the north and south will be reversed. This
So
might not refer to the
AR 3030 will retain north 30 degrees or whatever it is.
Right.
Yeah, it will
Goes
travel
around.
across the sun at this latitude. It will
Okay.
not drift down, but the next one produced will be down closer to the,
Ah, okay.
because the dynamics of the magnetic fields is twisting. It's a lot like those old rubber airplanes where you had a big rubber band and you wound the propeller up with your finger and you let it go. After you get if you ever did it too much, which all of us scientists did, we went to extremes and destroyed it to see what happened. But if you wind it till it holds as much energy as it can simply, and you keep winding it, then it starts forming knots. It doesn't wind up simply. Those knots are that twisting where it's trying to get out of its own way. And that's what's happening in the sun with these magnetic field lines. They're trying to get out of their own way and they're being pushed out of the sun.
but the sun has regular solar wind going out from everywhere all the time. This is just an eruption
Yes.
in the middle of it. That
It's
adds
it's a
Right.
complicated system. If it didn't have this rotation, which is hard to imagine, differential rotation, it would just simply have a simple radial outflow of plasma. So,
And so the light gets here in speed of light, and the particles get here hundreds of miles an hour or whatever, a little
Hundreds
earlier.
of thousands of miles an hour for some of them.
It takes them several days.
Okay.
yeah.
Many days.
One of those flares you're talking about, that's not just heavy light or energy. That's mostly
mass.
matter. Huh?
No, the
Yes.
flare is pretty much light energy and stuff like that, light and heat. The coronal mass ejection is where there's actual particles that really get accelerated towards us.
Well, this may be a little too early to talk about, but I'm curious if science thinks that all stars have this sort of thing going on among them. They can't see it, I'd imagine, yet.
Well,
Maybe the Webb will.
It depends on the convection cells and things that they have inside of them. So it varies with the type of star.
Okay. Red giants would be turning slower, perhaps.
One of the dominant effects of some very big stars like Vega and Betelgeuse is that they are spinning so fast on their axis that they're actually very oblate. They're not spherical at all.
Well, that's not Betelgeuse. Betelgeuse is very convective and probably rotating really slowly and has large spots.
And there's one we talked about that was a red giant. But anyway, I'm sure you but some of them are distorted, and so they probably have very complicated convective motions and differential rotations. So they're trying to figure out each star on its own basis. This is a historical, a medieval diagram of sunspots. So I guess there must have been one big one up in the north and one smaller one in the south. And what all the rest of it is, I don't know. It looks like it in shorthand, Latin or Arabic, pardon something. So
back then,
it looks like it's just filigree.
Looks like what?
Anyway, Wikipedia claims this is a early sunspot diagram.
Yeah, it looks like Latin, and then there's some obvious shorthand going on.
Yeah.
So back in ancient times, they would put smoked glass over the lens of their telescope.
Well, that's only after 1600, after Galileo.
Yeah.
Yeah, but they're not gonna blow up the sun without a telescope, and they're not gonna want to look directly.
Right, but you can do a pinhole projection and still get an image.
Oh,
Actually,
yeah.
my feeling is that this science started one day when a teenage girl was sent to the market to get a colander, and she was walking home, and she looked at the shadow of the colander on the ground and said, "My God, there's sunspots."
The reason I brought up smoked glass is I think it was probably around 1945. There was an eclipse that was visible in the Bay Area where I grew up. And my dad smoked glass. I remember 2 pieces, and we put them together so the smoke was in the middle, so that I could go out and look at the solar eclipse. In fact, he called me from work to see if I could see it.
You suppose there's anything to those ancient stories about explorers winning over the populace of the natives?
Absolutely. Columbus did that.
He knew there was an eclipse coming?
Oh, yeah, that's right. Yeah.
Oh my God.
They thought he was magic.
Right.
He was a deity.
Also in an old Bob Newhart routine, he was visiting some natives and decided to blot out the sun if they didn't let him go. Gentlemen, we've run out of time almost. We got 5 minutes to talk about either asteroid 10 Hygeia or the big W Cassiopeia with a double whammy.
Well, let's do the planet lineup that Jerry just brought up.
All right, Mercury, that's in the morning. That's when you see them early before dawn. Actually, you get a dark sky for 2 hours tomorrow night when the moon takes its time and comes up full.
Well, that's in the evening, but
right.
But here, this is early morning. This is about what, 45 minutes before dawn. What's cool is the naked eye planets are lined up in order of their distance from the sun.
Okay.
So that won't happen again till 2041.
Are we looking at 6 of them?
Well, here it's
Uranus
also putting in it's putting in a bunch of other stuff like Uranus and Neptune.
Okay, I can't read it.
I don't see Uranus there.
Uranus is down by Venus.
Oh, there it is. Oh, yeah. Okay, they're not in order.
All the visible, the naked eye planets are in order.
Yes.
Right.
But Mercury's not available till the next morning.
Mercury is down low there in this image. It's probably going to start getting better about Friday, and it'll be probably most visible around the 24th, I think. But by then, things will have spread out a little more, too.
Okay. And I don't suppose it's possible for you to describe or explain why we have Venus as an evening star sometimes in the year and the morning star the other time.
Because it's closer to the sun than we are.
It goes around the sun faster than we do.
Okay.
Because it's closer, equal areas and equal time.
Okay. Is it the brightest object other than the moon?
Other than the moon and the sun.
Okay.
Now you can have, Jupiter and the other planets be morning and evening stars too. It's just that Venus is so bright, people really noticed it. Plus it would pop up and go away and then pop up, over a shorter period of time. So at first they actually thought it was 2 different planets. They called it like Vesperus and Hesperus.
Well, we're getting what is it called? The closest to the moon, the perigee. This week,
Phrygian moon, yeah, super moon.
222,000 something miles out instead of 240. When is apogee? Is that halfway in the month?
Halfway between perigees.
Halfway? I thought it was the furthest out.
It is.
So that's when it's farthest
Right.
out, but timing is halfway.
It's on the opposite side of its orbit.
Yeah. Another cool thing about this lineup of planets is coming up, you know, gradually as the moon moves into the morning sky, it's going to be marching down this line of planets.
And our moon is pretty much above the equator, right, of Earth?
Yeah, it's in the plane of the ecliptic, but then tilted an extra 5 degrees from that.
Yeah, so it's right now it's below our celestial equator when it's full, because it's in the south, it's real low.
Okay.
But by the time it gets up here, it will be in line with those planets.
But the perigee thing doesn't make it fill up any more of the sky, does it? More than half a degree?
Tiny bit, yeah.
A little bit?
You don't notice it, but yeah.
Okay. Any of you plan to go out and set up your scopes for that? Or maybe Friday night at Westmont? Still be,
Perigee is an event for me.
It's a morning thing, Ron.
oh,
Yeah.
it's all morning.
Lately, I haven't seen it because it's all been fogged out here in the morning.
On Wednesday, we're supposed to have 2 hours after sundown, Sunday evening, right? And
Well, it changes by 40 minutes a day. So when it's full, it rises when the sun sets.
right.
And then after that, it's 40 minutes later each night.
So at Westmont, will you have a dark sky? No moon?
For a little while.
For a
For a
little-
little bit, yeah.
Okay.
And I think tomorrow is the earliest sunrise, if I remember right. 14th.
It will have started its waning phase on Friday.
Yeah.
You want to repeat that? What time is that? Westmont?
Westmont, the website says 7 o'clock. So we usually go to start setting up by that time, but it's not going to get dark until almost 9.
Yeah, right.
And then the clouds will come in.
Yeah.
How soon, Mr. Murdoch, do you think you'll be up and walking around and wearing a mask and not coming to
As lo-
meetings?
As soon as the COVID infection rate has a negative slope, it's got a positive slope now.
You may be indoors for the rest of your life. You and Art Harris, he's a germaphobe too. Poor
Well,
Art.
you know, I went through that viral pneumonia and I survived. I don't want to end up with COVID and not survive.
Right.
Yeah, I'm the same way.
I share your feelings. I'm nervous.
Well, gentlemen, I believe you alluded, Jerry, to things we could be talking about in the future, more on electrical fields and magnetic fields, and we'll get into the sky next week. And doggone, we've got a meeting on the 1st of July. That'll be our next general meeting, and that'll be our last one online from our living rooms or bedrooms or wherever we sit. And then we're going to
My
try to
office.
open, yeah, and a webinar on August the 5th. I will tell you briefly that it's a NASA scientist that JPL provided named Dr. Rob Zellum, who will be talking to us mostly about life on exoplanets or the possible life they're looking for. And I guess he'll know that, or he'll tell us about the 5,000 plus exos they've discovered so far. That'll be the night of the 1st of July. You're all invited to tune in. And we'll see you next Monday, I guess, everybody. Thank you for convening.
Oh, wait, one brief thing. This is from Bruce, I think.
Oh, that's from Tom Totten.
Oh, it's from Tom?
Okay.
Okay. So I think he's indicating that the Hercules
The
The
Tau
Tau-
Herculis, yeah.
meteor, that this is one that came right at him.
No, he's marking the radiant point there.
Oh,
And somewhere up near the top, I don't think it'll show if you zoom it in here because it's very dim, but there's a little question mark. Is this a
radiant.
meteor? Up. If you go up from, you keep
Yeah,
going,
right
right
there.
about there. He saw a streak that he thought might have been one of the meteors.
okay,
And then he put in the constellation outlines here just to help orient everything.
okay.
The only one I saw, it was coming, I think it was coming almost straight at me. And all it did is get brighter and brighter and brighter, and then poof, it was out.
Yeah.
Yeah, Tim Crawford said it's a good thing it wasn't the size of the one that wiped out the dinosaurs.
Coming right at us, yeah.
Would have
So anyway, I think it was a non-event.
But
Yeah, I saw.
otherwise, these streaks are stars, right?
Yes.
And Tom took this picture?
Yes.
Yeah.
Time lapse? Okay.
Yes,
We were
obviously.
out
Sounds
at
like about
Refugio. We were out at Refugio a couple of nights after, I guess Friday night after the Monday evening peak, and there was a huge bolide, a huge fireball that came by. So and it seemed to come from that radiant. So I'm wondering if there's still, junk spread out in the orbit that we're occasionally encountering.
I saw one in the morning, Chuck,
Yeah.
But this
before the
was
sun
called,
came.
this was called the Herculid.
Tau Herculids. Yeah.
Yes.
It was a speculative potential new meteor
Yeah.
shower.
Has anybody counted the number of the different radiants we have during a
Oh,
year?
There's lots of them.
Leonids. Well, are we done, or we'll get to other
We
things?
are done.
All right. Thanks for sending the silly stuff. Those cartoons brighten our day.
If anyone
There's our
wants
cup.
one of our coveted coffee cups,
Yeah,
go to our website, look up the merch manager.
yeah. That went to Tim
Equal
Brett.
prices. Coffee not included.
There you go. Okay, my friends.
Okay.
We
See
will
you next
convene
week.
again from our dens next week. Take care for the Santa Barbara Astro Hour number 68. Next week, number 69. Thank you.